Another property of Laplace transform, which we're going to look at now, is called S-shift. As you can guess, it means that we are going to shift something in the S-domain rather than in time domain. So again, let's say we know a Laplace transform of some function, and this time we want to know what's going to happen if you want to take a Laplace transform of this function multiplied by an exponential. And again, let's use the definition. By definition, it's an integral, and we're going to simplify this integral by combining these two exponentials into one, and you have this joint power, and if you look closely at this integral, you'll realize that that's just a Laplace transform, but of a function with a shifted argument. So it's again just by definition. And that was all we needed to state this property, this theorem. So that's called an S-shift or frequency shift, because that really corresponds to frequency in many applications. So if you know a Laplace transform of a function and you want to know a Laplace transform of that function with exponential, you just shift your Laplace transform by that amount. One thing I want you to pay attention here is that if you shift with the exponential to the power of a, where a say is positive, then the shift will be negative. So that's unlike in time delay. So here if we multiply say by exponential to the power of 2t, then the shift will be minus 2t. That's one thing to remember. It's time for another example of the S-shift. So let's find a Laplace transform of a power, a cubic function with the exponential. How to do it? Let's use the table. So we first find a Laplace transform of a cubic function, which from the tables is that. And then we use the S-shift to combine this table expression with the Laplace transform factorized with the exponential. So plugging in that into here, we will be able to solve this example. Again, pay attention that because you have minus power in the exponential, you have plus shift in the Laplace transform. So the answer is, by just applying this here, you get that. So it's 6 over s plus 2 squared to the power of 4.